So this week we will be looking at 3.3 through 3.5. The goal is to try to pretty much do one section each day. My plan is to also stay after school on Wednesday because the test is going to be Thursday. So if there's anything you want to go over before the test, that's the day I'll be after this week. Okay, so just a reminder about what it means for something to be a root or to be a zero. It means that it's a number you can plug in to a formula, and when you plug it in, you get an answer of 0. So if you had something like f of x equals 3x minus 6, what would be the root to that equation? Yeah, it would be 2. So 2 is what we would call the root. Or you could also say 2 is the 0 of the equation. Okay, so any question on what a root is? Some equations have more than one root. It depends. Generally, as the degree of the equation goes up, you have more answers. So that's a linear. If we did a quadratic, we could have 2 roots. So what we're going to do is we're going to use long division to help us find roots of polynomials. So we use long division to help us factor polynomials, which then factoring helps us to find the roots. So that's why we really use long division. So let me show you an example without any letters first, just with numbers, so you can get an idea of what we're going to do. So let's say that I wanted you to factor the number 12. That means I want you to write 12 as something times something. I want you to figure out what 2 things you can multiply together to get 12. And I'll give you a hint. 3 is one of the factors I want you to use. The goal is to solve for the question mark. So we know that 3 times something is going to give me 12. How would you solve for the something?
Division.
Yeah, and what would you divide each side by?
3.
You divide each side by 3. So in this case, if you divide each side by 3, you'd get 12 divided by 3, which gives you 4. Now you can go back and check it. We know 3 times something was supposed to give us 12. We did the division and we got 4. If we check it, 3 times 4, yep, that gives me 12. Now the important thing to notice right here, we knew 3 was a factor of 12. When you divide 3 into 12, what's the remainder? 0. Anytime you divide a number by a factor of that number, you will always get a remainder of 0. If I take 12 and I divide by 5, do I get a remainder of 0? No. And that means 5 is not a factor of 12. So remainders, I'm going to learn a little more about it, but remainders are a quick way to figure out if one thing is a factor of another. Do you divide it in and get a remainder of 0? If so, then that thing you divided by is a factor. If not, it's not a factor. Right? So what we're going to do is, let's say that you had to factor this, x squared, and again, I'm not going to do this all out, I'm just going to kind of show you the concept. Let's say we had x squared plus 3x plus 2, and I wanted you to factor it. And I gave you a hint, and I said x plus 1 is a factor. And you weren't sure how to find this one. Well, it's the same thing we did with the number 12. You could use division, and what could you divide each side by?
X plus 1.
You could divide each side by x plus 1. And if you can figure out what that comes out to, that's the answer to the question. So that's what I'm going to show you how to do. So it's long division, just like with numbers, except it has letters. It's the same concept. I said that to you a minute ago. If you divide two things and you get a remainder of 0, then what you divided by is a factor. So the other thing we're going to want to figure out is there a quicker way to find the remainder? Yes, you can always do long division, and you will get the remainder. Long division is good if you need the quotient and the remainder. You have to do long division. But what if you just want the remainder? Is there a faster way we could just get that? And the answer is yes, some of the time. So I'm going to show you a faster way to get the remainder if all you're trying to do is determine, is this a factor of that? You just need the remainder to answer that question. Unfortunately, the quick way that I'm going to show you to get the remainder, it doesn't work all the time. It only works in certain situations. So even though it's a nice shortcut, there might be times where you still have to do long division. So why do we factor something? Because looking at this compared to looking at this, it's a lot easier for me to look at what's on the right and tell you that if you plug in -1 and -2, it's going to give you the roots. When I look at it in its foiled out form, it's a lot harder for me to look at that and figure out what numbers can I plug in and get 0, because I'm looking at something with an x squared. Once I factor it, I don't have an x squared anymore. That's why it makes it easier. So that's where the process of long division is going to help us to find these factors if you can't figure it out. Now, I would think, or at this point I would hope, that for quadratic problems, most people would feel pretty comfortable factoring something like that. Where it gets a little harder is if this number is not a 2, but it's like a 3. You're not really taught how to factor things that have an exponent of 3 or 4 or 5. Sometimes there's little shortcuts, but in general, you don't learn as much about doing that. So I'm going to show you a way that you can do it. But you have to understand how to factor it, and you have to understand long division. So I'm going to show you the steps for doing long division. And what I'm going to do is I'm going to put the steps on the board. And then at the same time, I'll do a problem. So I'm going to do this kind of like side by side. So the problem that we're going to do is we're going to take x cubed minus 8x plus 3. If you wanted to think of it like in a fraction format, and you're going to divide that by x minus 3. It doesn't help me to write it this way. I'm just doing that for you guys as kind of a visual to show you what we're doing. That's the question we're going to solve. Okay, the first step is if the dividend is missing any terms, you need to fill in zeros. Okay, so what do I mean fill in zeros? Just put that up there. Well, the dividend is the part on the inside. Okay, that's the x cubed minus 8x plus 3. When you write your dividend, you need to leave space for every exponent from the highest all the way to the lowest. There's an exponent missing. What's the exponent that's missing in that dividend? Yeah?
X squared.
X squared. So because we don't have any x squareds, we need space in case we need to write some down. So we're going to create an empty column for the x squareds. And the way we're going to do it is like this. Put in 0 x squareds. There are 0 of them. But what that does is it gives me like space to write some things down. And you are going to need space. Okay, so make sure you put that in. Okay, that's your first step. Any questions on that? Okay, second step. You're going to take the first term of the divisor, which is x, and you're going to divide that into the first term of the dividend, which is x cubed. I just wrote it as x times x times x because I think it'll make it easier for people to see what's going to happen. Now, if you're wondering, what about this minus 3? You don't do anything with it yet. It just stays there for now. So let's do that out. What's x cubed divided by x? Yeah.
Would it be x squared?
That would be x squared, because an x cancels from the top and the bottom. So that's step 2. We divide. And this follows kind of the pattern you might be used to with regular long division. Divide, multiply, subtract, bring down. That's the pattern. So the next thing is multiply. We're going to take our answer that we just did and multiply it back out. And here's where we have to line up like terms. What's x squared times x? X cubed. So we're going to put that in the x cubed column. What's x squared times negative 3?
Negative 3x squared.
Negative 3x squared. So this is why you needed space for things with an exponent of 2. We just got one. If we didn't create that column, we wouldn't have had anywhere to put it. Any question on multiplying that back out and putting the answers in the appropriate column? Okay, so step 4 is to subtract the columns. Subtract the columns from the last step. So the way that I do it is I go like this. For parentheses, because you're subtracting that whole thing we just did. Now, what's x cubed minus x cubed? Yep. 0. Okay, that's going to cancel out. What's 0x squared minus 3x squared?
Positive 3x squared.
Positive 3x squared. And that's it for step 4. Any question on that step? Yes?
Sorry, I probably should ask it. Where did the negative 3x squared come from?
When that came from multiplying x squared times negative 3.
Oh, right.
Now we need to do the whole process again. So bring down the next term. And we're going to repeat that process. So the next term is 8x. You need to keep going until the number on the inside, which is now a 2, is smaller than the number on the outside, which was an x to the first. So we started with a 3 on the inside. Now we're down to a 2 on the inside. That number is going to go down 1. It's going to go down at least 1 every time. Sometimes it goes down 2 if you get multiple things that cancel. But here we didn't. Okay, so now divide the first term on the outside into the first term on the inside. 3x squared divided by x. Okay. What's 3x squared divided by x? Yep.
3x.
3x. Those cancel. Now, we're going to take the 3x, multiply it back out to each term. What's 3x times x?
3x squared.
3x squared. And what's 3x times negative 3? Negative 9x, good. And now we've got these columns. What am I going to do with those columns? Subtract. What's 3x squared minus 3x squared? 0. If something is always, you're always going to get at least one thing that cancels. If you get 2, that's great, because it speeds it up. Okay, negative 8x minus 9x. Right, that's negative 8 plus 9 is positive 1. Bring down the next term. What's the exponent of the variable that's on the inside? 1. What's the exponent of the variable that's on the outside? 1. So we need to keep going until the number on the inside is smaller. And this will be our last round, and then it will be. Okay, brought down my next term. Take the first term on the outside, divide by the first term on the inside. What's x divided by x?
0.
1. Okay. What do we do with the 1? Multiply it. Okay, what's 1 times x? 1 times negative 3. And now what do we do with these columns? Subtract. Okay, x minus x? 0. 3 minus minus 3? 6. Okay, what do you think that 6 is? That's my remainder. And because I didn't get a remainder of 0, that tells me something important about what I divided by. What do you think that tells me about x minus 3? It's not a factor. So if you were trying to factor x cubed minus 8x plus 3, that is not what you should use. We're not trying to factor it. We just tried to do the division. Okay, so final answer. There's 2 ways you can write it. You can write it as quotient and remainder, 2 separate boxes. Or you can write it the way you do with numbers when you learn long division in elementary school. If I take 17 and I divide by 5, what's my quotient? 3. And what's my remainder?
2 fifths.
Remainder, it has to be a whole number.
0.4.
What is it?
0.4.
That's rational.
Oh,
That wouldn't be a whole number. Can't be a decimal. Yeah. Remainder is 2. So the quotient is 3, the remainder is 2. And the way you're taught you can write your answer is take your quotient plus your remainder and put it over your divisor. So the quotient is 3 and the remainder is 2. And what I divided by originally was 5. So the answer when you divide 17 by 5 is 3 plus 2 fifths. Or sometimes you learn to write it as a mixed number. Now we're not going to be able to write it as a mixed number because we're doing letters. Okay? But that's the important idea. Quotient plus remainder divided by my original divisor, x minus 3. That is another way you can write your final answer. I just didn't quite write it on the same line. But. Any question on either way? What's nice about the second way is you could type that in y1, and then you could type this in y2. And if you did the problem right, what do you think would happen? They would be exactly the same picture. Because that's the original problem, and that's what you think the answer is to the original problem. So they should be equal if you did it right. And they would be. Does anybody want me to graph the original in y1 and the answer in y2? Show you they're the same? Want to see it? Okay. When you type it in, you just need parentheses because both numerator and denominator are polynomials. So we got what is it? X raised to the third. I don't know why I put this 8 here. I'm not sure where I got that from. So x to the third minus 8x minus 8x plus 3, and then divide by x minus 3. Okay, that's the original problem. And the answer that I think is x squared plus 3x plus 1 plus, in parentheses, 6 divided by x minus 3. That's how I would type in our answer. Let's do zoom 6 and see if they look the same. Now, looking the same, it doesn't prove it's the answer. Proving it's the answer means do the algebra like we did. But if they look the same, then it highly suggests we did it right. So they are the same thing. The red one just traced right over the blue one. Any question on that? Yeah?
Why doesn't that mean that it's like a definitive answer?
Because a graph can never be used as a proof. Because I don't know, what if I zoom out to 1,000,000 and then all of a sudden the graph is a little different? We don't know because we can't zoom out forever and see it. And we also don't know, are these lines really right on top of each other? Or are they like 0.01 off and you can't even see that in a graph? You know what I mean? So like I could draw two things. Like if I did x squared and I did x squared plus 0.0001. I bet if anybody walked in right now and just watched what's happening on the screen, they'd say, okay, there's the blue one. There's the red one. Yeah, they look the same, but they're not. They're a little bit different, but you can't see that level of detail on the graph. Okay. So that's a long division. Let's try another one. Okay, this time I set it up for you with the zeros that were missing included. On the test, the missing zeros will not be there for you. You will need to fill those in. Now, you might have noticed from the first problem, but when you do long division, the work goes down and to the right. So when you set up your problem, you don't want to put a long division problem right on the right edge of your paper. Okay. You want to put it closer to the left because it's going to go that way, down and to the right. Okay, what's going to be the first, and I just write this off to the side, what's going to be the first two things I divide in this one? Yeah?
2x to the...
So 2x to the fourth. You don't have to write it this way. I'm just trying to help people out. 2x to the fourth. Yep.
over 2x squared.
Perfect. Over 2x squared. When you simplify that, what's left?
2x squared.
Yep. 2xx, 2xx. You're left with x squared. Okay. Now, what do we do with the x squared? Multiply it back out. What's x squared times 2x squared?
2x to the fourth.
2x to the fourth. What's x squared times x?
X cubed.
X cubed. And what's x squared times 1?
X squared.
X squared. Okay, now what do we do with the columns?
Subtract.
Subtract. 2x to the fourth minus 2x to the fourth. What's negative 1x cubed minus x cubed? That's negative 2x cubed. And 0x squared minus x squared.
Negative x squared.
Negative x squared. bring down the next term. I know it's just a 0x, but it helps people usually if they just see it. Okay. All right, now, what's the next? Now, I got a 3 here and I got a 2 here. I need to keep going. What's the next division that I'm going to do? Yeah?
Negative 2x cubed.
Negative 2x cubed divided by
2x squared.
2x squared. Okay. What am I going to be left with when I do that? 2xx, 2xx, you're left with negative x. Okay, multiply back out. What's negative x times 2x squared?
Negative 3x squared.
Negative 2x cubed.
Negative 2x cubed. What's negative x times positive x?
Negative x. Negative x squared.
Negative x squared. And what's negative x times 1? Negative x. And again, subtract those columns. What's negative 2x cubed minus 2x cubed? 0. What's negative x squared minus negative x squared?
0.
It's also 0. So I told you sometimes you could get two things that cancel. That's a case where it did. And now we're basically going to be done. What's 0x minus x? X. And that x is part of your what?
Remainder.
Part of my remainder, because the exponent on x is a what? 1. The exponent on the outside? Well, you can't keep going because there's not enough x's left in the top. Okay? But that's only part of my remainder. What else is part of my remainder? Right, don't forget to bring down the negative 2. Okay, so in this case, quotient and remainder. And again, that's one of the two ways I showed you could write it. The downside to this is you can't type that in on the calculator that way if you wanted to check it.
Wouldn't the quotient just be x squared minus
Oh, I'm sorry, I copied down the wrong thing. I copied the divisor. Yes, thank you. So don't do all the work right, get everything right, and then don't look at any of your work when you write the answer. So yes, the quotient is x squared minus x, and your remainder is x minus 2. Yes?
Can you write it the other way?
Yep, the other way. So quotient plus remainder over divisor. 2x squared plus x plus 1. That's the other way. Quotient plus remainder over divisor. And now if you graph what's in that bottom box in y1, graph the original problem in y2, they should look the same. I'm not going to graph on this time. Okay, any question on that one? So at first it looked like that could have been a longer problem because you noticed it was a 4th degree and it had more terms, but all the work was basically right there compared to the first problem, which wasn't as high of a degree. It was only cubic, but I think there was more rounds of that division you had to do. We had to do 3 rounds, where here we only did 2. So higher exponent doesn't necessarily mean it's going to be a longer problem. Okay? Depends. All right, so what I want to do now is look at this. Okay, this is called the remainder theorem. The remainder theorem gives you a quick way to find the remainder as long as you are dividing by something relatively simple. This theorem works as long as the denominator is of the form x minus a number. So to use this theorem, you had a problem like this, it will work. What's going to be important is the number that's in that box. All you have to do to find the remainder, if you're dividing by something that's x minus a number, is take the number that's in the box, not the minus sign with it, just the number in the box, and plug that number into the top. That's a trick that will quickly give you the remainder. But it does rely on the denominator being x minus a number. So in the last problem that we did, this was my denominator. Is what I just circled x minus a number? No. So then if you want to get the remainder on this problem, you have to do long division. Let's go back and look at the first one. Was the denominator on the first problem, right here, x minus a number? Yeah. What's the number that's in the box after the minus sign? It's a 3. So let's take the number 3 and let's fill it into the top and watch what happens. Here's the top. X cubed minus 8x plus 3. Fill in the number after the minus sign. 3. 3 cubed minus 8 times 3 plus 3. What's 3 cubed?
27.
27. What's 8 times 3? 24. What's 27 minus 24? 3. And what's 3 plus 3? So we got 6. What was the remainder when we did this problem with long division? 6. Exactly the same thing. So it worked. So that's a quick way to find the remainder. And again, if you're wondering, well, why do you want to find remainder? Because when the remainder is 0, then that means it's a factor. And that's so sometimes that's all we want to know. Okay, is something a factor? So anywhere in the homework that you say that it says something like determine if something is a factor of something, they might say in the book use the factor theorem. I always want you to use the remainder theorem. So the remainder theorem means you just find the remainder, and if it comes out to 0, it's a factor. Okay? So just ignore the word factor theorem in the book because we're not really going to learn that. That's the theorem we're going to learn. Okay, so let's try this one. Now, do you have to use the remainder theorem? No. If you want to do long division, you can. But I might give you a long division problem that would be very difficult, where using the remainder theorem would be very easy. So I would really suggest you learn the remainder theorem. Okay. So find the remainder when, we're actually going to do 2 questions. We're going to divide f of x by h of x and find the remainder. First of all, is what I'm dividing by right in that box, does it fit the pattern that it needs to use the remainder theorem? Yep, it's fine. So we're going to do that one first. Then we're going to do that one. We're going to divide by x plus 1. Does g of x fit the pattern that it needs to? Ariel, what do you think? No, not the way it's written. But we could fix that, and it would be. So we'll talk about g of x in a minute. So let's start with f of x divided by h of x. I'm going to find the remainder. First thing is, what is the number that's after the minus sign? 3. And what am I going to plug that 3 into? X in which equation? F of x. So we're going to find f of 3, and that's your remainder. So 3 cubed 2 times 3 squared plus 3 minus 5. Okay, 3 cubed, we just did that, it's 27. 3 squared is how much? 9 times 2. So we get 18. What's 27 minus 18? 9. What's 9 plus 3?
12.
And minus 5.
7.
There you go. Right? If we were doing long division, there is no way we would have been done yet. We'd still be doing it. So now if I said, is x minus 3 a factor of f of x?
No.
No. We got a remainder of 7. If something doesn't divide evenly into something, then it's not a factor. Okay. Now let's do f of x divided by g of x. Now the problem this time is g of x is not set up the right way, but it could be. How could I rewrite g of x? So it's x minus a number, and then it's the number that's in this box that's going to be important. Yep.
X minus -1.
X minus -1. Exactly. So now, what's the number that I'm going to use this time? -1. And what formula do I plug it into? F of x. Okay, so let's do that out. We're going to get -1 cubed, 2 times -1 squared, minus 1 minus 5. Okay, what's -1 cubed? -1. What's -1 squared? 1 times -2. And -1 minus 2? -3 minus 1 more? -4 minus 5 more? -9. And there's your remainder. So now, is g of x a factor of f of x? Nope. Didn't go in without a remainder. So I don't know why a lot of people get confused with the remainder theorem on the test, but that's how you do it. Take the number after the minus sign and fill it into the formula that's in the top. Maybe they just mix it up and they accidentally plug in like a -3 when you really should be plugging in a +3 there. I don't know. But, and again, if you're thinking, well, I won't ever need that, I'm just going to do long division. Okay, well, what if I said x to the 48th minus 3x to the 5th plus 7 divided by x minus 1. And I said, find the remainder. Well, the problem is, to do long division, you need to fill zeros in for every term you're missing. So you're going to fill in zeros from the 47th term all the way to the 6th. It's a lot of columns of zeros. And then you need to fill in zeros for the 4th, 3rd, squared, and linear too. So versus if you use the remainder theorem, all you have to do is take the number 1, fill it in the top. 1 to the 48th power is 1. 1 times 3 is 3. 1 to the 5th power is 1. 1 times 3 is minus 3. And then plus 7. So the remainder, when you do all that out, is 3 minus 3 plus 7, or 7. It's much, much faster than trying to do the long division. All right, so factor theorem, I already told you we're not really going to talk about that. So when you see that in the book, just mentally change that in your head to remainder. Now it says use the remainder theorem to show that this is a factor. So if it's a factor, what does that mean is going to happen?
It'll come out to 0.
When you do the division, you get a remainder of 0. So instead of doing the division, just find the remainder. Skip the division. if I want to know the remainder, how would I have to think of x plus 2? If you want to use the remainder theorem, you can't think of it as x plus 2. Yeah?
X minus minus 2.
X minus 2. Now, what's the number that I'm going to use there? Negative 2. And what am I going to plug it into?
X cubed.
Yep.
Plus 5x squared plus 5x minus 2.
So plug negative 2 into the x cubed. Plus 5x squared. Okay, let's see what we get. What's negative 2 cubed? Negative 8. What's negative 2 squared?
4.
Times 5? 20. Minus 10 minus 2. Okay, what's negative 8 plus 20? 12. What's 12 minus 10? 2. And 2 minus 2? 0. And what is that 0? That's my remainder. And because the remainder comes out to 0, what does that mean about x plus 2?
It's a factor.
It's a factor, exactly. So now, if we were trying to factor x cubed plus 5x squared plus 5x minus 2, I'm going to do the same thing I did when we tried to factor the number 12. I'll give you a hint. One of the factors is x plus 2. How would you get the other factor?
Divided by x plus 2.
Right. You divide this whole thing by x plus 2. And then you have to do the long division. There's no shortcut. Well, there is a shortcut, but it works some of the time, and I'll show you that tomorrow. But yeah, you do the long division for today. And that would be the question mark. So the question mark would be your quotient when you do the long division, and we already know the remainder would come out to 0. Okay, any question on that? All right, so some statements here that are all equivalent statements about roots and zeros. If you have a number that you can plug into an equation, and that number gives you an answer of 0, then the number you plugged in is called a root. That number that you plugged in is a solution when you set the equation equal to 0. That number is also called a 0. But there's something else that's important. And let me show you, and then I think you'll be able to figure out. Let's do could somebody factor that for me? X squared minus x minus 6. Yeah. X minus 3, x plus 2. Now, can somebody else tell me what are the two numbers that I could plug in that would make this 0? Yeah.
3 and 2.
X equals 3 and x equals negative 2. Any question on how we got those two numbers? Now, I want to work backwards. Let's say that I told you x equals 4 and x equals negative 5 were the roots. What would be the factors that those came from? So what I'm getting at here is if you know the roots, then you should automatically know the factors that they came from. So what about x equals 4? What would be the factor that would come from?
X minus 4.
Right, x minus 4. And x equals negative 5 would have come from x plus 5. So if you know a root, then x minus that number is the factor. Same thing here. The root was -5. X minus -5 is the factor. That's always the pattern. So if c is the root, x minus that is the factor. And what that allows us to do is work backwards, and I could give you a problem like 4 and -5 are the roots. You tell me the equation that they came from. So it's like reverse of what we just did. Right, so we got 2 questions left we'll do. One we're going to work backwards from the roots and figure out the equation. And the other one we're going to start with the equation and work towards the roots. So we'll try it each way. And one other thing. So there are roots, there are zeros, x minus the number is a factor. What about if you graph it? If you graph this problem, what's going to happen at 3 and -2 on the x-axis? Yeah?
The line crosses the x-intercept.
Yeah, or in this case it's a curve, but yeah, it's where it crosses the x-axis. So if you know the roots and you were to draw a picture, you also know where it crosses the x-axis. Because we've done that on the calculator, I think, second calc 0, to find roots. Okay, so these are really all different ways of saying the same thing. All these ideas are tied together. Factors, x-intercepts, roots, and zeros. Okay, so let's look at this one. It says, find a polynomial of degree 3. That means when you FOIL it all out, the highest exponent will be a 3. Now, another way I could ask this exact same question would be, find a polynomial that crosses the x-axis at -2, +1, +3. That's exactly the same question. It's a different way of me wording it. Another very small change I could do in the wording, I could say, find a polynomial of degree 3 that has roots of -2, 1, and 3. Roots and zeros are synonyms. Same thing. Okay, so the first step is, if you know the roots, work back to the factors. That's step 1. If -2 is a root, what would be the factor that it came from? Yeah?
X plus 2.
X plus 2. How about if 1 is a root?
X minus 1.
X minus 1. And if 3 is a root?
X minus 2.
X minus 3. Now, they said to find a polynomial of degree 3. That's not degree 3, that's factored. They want you to do all that out. Okay, so let's start with the first 2. What's x times x? X squared. X times -1. So I'm just going to put that up there for a second. And 2 times x.
2x.
What's -1x plus 2x?
X.
X. And 2 times -1.
-2.
-2. Okay. And now we do it one more time. Multiply that times your last root. Probably not going to ask you to do more than 3 roots, because then if you had to do like 5 or 6, the foiling starts to take a long time. Okay. All right. What's x times x squared?
X cubed.
X cubed. X times x?
X squared.
X times -2?
-2x.
And now do the -3. -3 times x squared.
-3x squared.
-3 times x.
-3x.
Good. And -3 times -2.
6.
6. Okay. Combine that and get your final answer. So x cubed. Got that one. How about my x squared terms?
-2x squared.
-2x squared. My x's? constant?
6.
6. So now, how could I check that that crosses the x-axis at negative 2, 1, and 3?
Plug it in the calculator.
We could check it, yeah, by graphing it. So let's type in x cubed minus 2x squared minus 5x plus 6. I'll do zoom 6. And remember, looking for negative 2, positive 1, and positive 3. Okay. What do you think? Does that look like negative 2, positive 1, positive 3?
Yeah.
Yep. Perfect. So any questions on starting with roots and working your way to the polynomial? Now we're going to try that exact same idea, and this will be our last one, but in reverse. I'm going to start you with the polynomial, and I'm going to have you work backwards to the roots. The factors are always kind of the step in the middle. Factors can help you go either way. So that's what we have to find first here. And they give you a hint to use factor by grouping. So this is kind of like what the final answer was in the last problem. Okay, the first step now is to try to factor. And forget about the last two terms. With factor by grouping, you look at the first two and factor out what you can. Now we'll look at the last two after. What do the first two terms have in common? So we're going to put that on the outside of parentheses. Okay, so we were factoring out x squared. And if you factor out x squared, what does that leave you with inside your parentheses?
X plus 2.
X plus 2. Now, the whole goal with factor by grouping is you need to get another x plus 2. If you don't, then factor by grouping is not going to work. But since that was my hint, it probably works. What does this term and that term have in common?
-4.
A negative and a 4. What would be left inside the parentheses if you factor out a negative 4 from both? It would be another x plus 2, because that would give you negative 4x minus 8. Perfect. So now we know factor by grouping is going to work. Now, look at that and look at that. What does the two things I have underlined in red, what do both of those have in common?
X plus 2.
So now we take the x plus 2 out. And if you take that out from the first one, what's the only thing that's left?
X squared.
Just the x squared. And what if you take it out from the second one? Minus 4. All right. So now we almost have our factors. At this step, we're kind of like where we were towards the beginning of the last problem. So we're getting there. How does x squared minus 4 factor? Because that's a difference of 2 squares. Yeah?
X plus 2, x minus
Perfect. Now we're back to the point where we have our 3 factors. We can find the roots. What would you plug in to make the first factor 0? Negative 2. How about the second factor?
-2.
So that's what we call a repeated root. You don't have to write the answer twice. Okay? Just a repeated root. And then how about here? 2. Okay, so the roots are plus or minus 2. So how would that look if we graph that? Well, how many times is it going to cross the x-axis? Yeah, it's only going to cross twice. So what that means is it's going to come up to the axis, it's going to touch it and then bounce away from it. It's not going to cross through it at one of the points. That's the only way it can cross twice. So watch for 2 and negative 2. There you go. So it comes up, and with a repeated root, it bounces away, because if it went through, it would have to come back down somewhere else, and then go back through again, and then you get 3. But in this case, there's only 2. I mean, technically there's 3, but one of the answers is a repeat. Okay. Any questions on that? So tomorrow, I'm going to show you a slightly faster way to do long division. But the downside is it's like the remainder theorem. It only works some of the time. But when it does work, it's a lot faster than long division. It's called synthetic division. So we'll look at that tomorrow. Okay, so there's the homework for tonight. Just a reminder too, I will be after school on Wednesday because we're going to have our test on Thursday this week. You will have time on Friday if you need to finish the test. But you will have to give me all your materials on Thursday. So if you want to make a reference sheet, that's fine. But you can't see the test on Thursday, go home and make a reference sheet, and then bring it in Friday. Okay, so if you want to make a reference sheet, you'll have to have it for the test on Thursday. Any question on that?
For that, is it 20 through 25 or 20 and then 25?
20 and then 25. Yeah.